Hey guys, it's John at SynRC, and it has been a crappy week for flying. I'm talking like nonstop wind, nonstop rain. We've got a cold front pushing its way through right now. We're actually supposed to get some snow here in the central part of North Carolina finally. That'll be amazing to see as a Florida native, getting to experience that. So to wrap this up, I went ahead and just redid my hangar room a bit. My wife and I decided it made more sense to split the two IKEA tables up and have all this space to really work with rather than having it be straight across, which makes these setup videos look so much, not easy, look so much better. It was a real mess before. So, this is a real blast from the past right here, the F-22. I haven't had this model since mid-September. I sold it and bought the 80mm F-16 and recently retired that because it was in pieces after my buddy accidentally flew it into a piece of rebar. So I'm going to go ahead and go over the discussion of how to set this thing up and how to get the most out of it. You guys have already, if you're familiar with my channel, you know what to expect here. But I wrote a little note down for myself so I know what to look for this time. So let's start with the physical changes that you need to do to this model to actually get a full Taileron, Flaperon configuration. So it's most easily seen from behind. My flaps move in concert with my ailerons, and my elevator stabilators, whatever you'd like to call them, move in concert with the ailerons and the flaperons. The end result is a plane that flies very much like the real thing. Having already flown this model previously, the only difference between the earlier version and this version is primarily the flaps. In the early version, the flaps didn't actually move as ailerons. I don't think it's going to make much of a difference here, but I do want that functionality just for the scale appearance and to have more control at lower speeds, especially for flat spins, J-turns, otherwise known as the Herps maneuver, things of that nature. So, to go over and get to this, the overall setup to get to this point, you'll need to have the wings off. I'll just walk you through it because I'm not going to take everything apart just to show you how it's done. It's really easy to walk you through it. You're going to take the landing gear wire, okay, and let me pull one of my spare landing gear out and I will demonstrate what it was that I did so you have an idea of what's going on. Let me get the string that I used. You're going to want a string. It's the easiest way to do this. The reason being is that the wiring for the wing is pulled through a couple of narrow channels that start about right here and run like this all the way in to the side of the wing. With the little Griffin wire that came with, you know, that bird right there, I couldn't actually fish it through. So what I first did was I cut the little servo leads out that Freewing had installed. Where are they at? Show them to you if I can find the damn things. Ah, here they are. So these things, they're just useless weight. If you're going to set this up to be full potential, you're going to want to take them out. I went ahead and just cut them because the leads are too thick at the end to actually pull out without damaging the plane. So I went ahead and cut at the end, pulled one end out, pulled the other end out. I then pulled the gear wire all the way out, or not all the way out, let me rephrase. I pulled the gear wire to, what was it? That's what it was. I did pull it all the way out. I'm sorry. I'm trying to remember how I did this. I pulled the socket end of the servo lead after tying the string to it. That's what I did. Okay, just like this. Go ahead and tie a string to the end of this. Make sure it's double knotted when you do it, because when you pull it through, there's going to be some potential resistance in there, especially as you start adding more of these wires. You tie the one end of the string. As you pull it through like this to the other side, you then have this. Okay, so you have the other string dangling off the side of the plane. You then pull this all the way through, okay, and leave that end right there. Tie the other end back to this so that you've got this string like this, and then you re-pull the wire all the way back through. So you've got a fully run string that you can then continually rerun and tie another servo lead to, okay? Once you do that, I'll demonstrate again. Just pull a random wire out of here. There we go, this is a good length. Once you do that, since you have the string literally sitting like this, you just tie the servo lead to the male port part of it. Go ahead and you connect it, wrap it around, attach the other side of this, pull it around one more time so the string never, it makes another loop, and then you pull the other set of servo lead through it. So you have 2 servo leads per wing, so you're going to have one of these and for the Flaperon, and then one for the Aileron, and you repeat that on both sides. To make sure you double knot it, like I said, otherwise you'll have to re-pull the gear wire through if it slips off. It's a real pain in the butt. Once you do it, you'll see what I'm talking about. I took the blue box out to get rid of the, because it really doesn't serve much of a purpose, and I replaced the blue box with the only thing it was doing was running the light, the nose light. So I went ahead and I replaced the blue box with the Freewing LED controller that I had in my airliner. I'll just order a separate one and put it back in there at some point. And that's pretty much, that's the real gist of it. The elevators already come with 2 separate servo leads that plug into the blue box, so you don't have to do much to get them to plug into each other. You just put them into separate channels. As you see my model, you'll see how I have mine set up. Currently running throttle to right aileron is channel 2, right elevator is channel 3, rudder is 4, left flap is 5, left aileron is 6, right flap is 7, auxiliary 3 is my gear, which is channel 8, channel 9 is left elevator, and auxiliary 5 is, what is that? That's the nose wheel, the nose door. Because I got rid of the blue box, I had to sequence my own door. So before we get to that point though, let's go ahead and talk about the motor choice. This is the ARF model. I'm running the FMS 1950 kV motor, the one that comes in the Viper 90mm. If you've been following my channel for a while, you may remember that I flew my Viper into a tree not long ago. So let me go ahead and show you what it looks like to get this thing to fit mostly flush. I could probably cut a little bit more, and will probably cut a little bit more to get it to be a little bit more flush with the model. Right now it's close enough to the surface of the fuselage that I don't think it's going to do much to affect the boundary layer surrounding the vehicle. So I'm not too worried about it, but just for aesthetics sake, I'm going to go ahead and shave it out. This is built for a Freewing motor, and I have a spare Freewing motor, in fact, that I will show you how it fits in there. Okay, so generally speaking, if I'm not mistaken, it should fit in here like so. Yep, that's exactly how it should fit. The problem is FMS motors are a little bit bigger, as you can see. They are not the same size. The FMS can is longer, and the motor is slightly bigger, but that motor weighs about half as much as this one. This is a much heavier motor than the FMS motor. If I'm not mistaken, from what I've read on RC groups, the FMS motor here is also more powerful by a decent margin. It takes a little bit more amperage to push it. I'm not an electrical engineer, and I'm definitely not a master of this kind of stuff, so you know, I don't like talking about subjects I'm not completely comfortable talking about. I'll talk to you all day about aerodynamics, but when it comes to power systems, I'm not the most intelligent. I need to brush up on it. But anyway, back to the point of fitting things. This does mostly fit. You just have to cut off this little part here to make it flush. I hit it with sandpaper, and then I pressed the piece in pretty hard until I could see the imprints of the motor, and then went ahead and just shaved out the little tabs that the motor was sitting in, and then used the screws that the ARF came with to screw it back into the plate there, and reran the Avian 130 amp that the Viper originally came with, and powered the it's got a separate BEC built in, so you don't really have to have all the additional weight that the Freewing setup comes with. It tends to have that separate BEC powering it. The 130 amp Avian doesn't have that. It's already internal. It's all part of it. So it's a really good setup. If I wanted to, I could have set it up for reverse thrust, but I don't think it's going to be necessary on this model, and I will show you why later on when I come to the topic of spoilers and other full-scale F-22 emulated features that I've programmed into this plane. So And then we talked about the motor choice and the weight reduction. I actually weighed this plane with the battery removed from the model on my little Publix weight stand that I had sitting on the edge over there. The plane weighs less with the motor in it than it does with just with nothing in it. So it actually doesn't weigh a whole lot. I think the whole thing weighs like, I'd say this is about 4 or 5 pounds right now. It's pretty damn lightweight. Maybe closer to 6 or 7 with a battery in it, but I mean, for a 90mm model, this thing is basically, it's a ferry. It doesn't weigh a whole lot. And the amount of deflection I've given this thing, it's going to tear through the sky. It's going to be amazing. I can't wait to see it. So let's go ahead and talk about the receiver. I would show you the receiver, but it would require that I take the battery tray out and unpower the plane. So I'll just go ahead and kind of describe it. Or better yet, I can just show you what it looks like, because it's in the F-15, and I couldn't hide it in the F-15 like I could with the F-22. It's the AR10360T. I'm using all 10 channels on it, unlike the F-15 here. The 10360T is an amazing receiver. It's not cheap. I paid quite a bit for it. I think it was close to $170 US dollars. Mine is sitting underneath the tray. I've got a satellite receiver for it, which is plugged into the SR-XL2 port. You can get these if you go to Spectrum RC, you'll actually see what the recommended receiver is. Mine is the one with the additional antennae on it, so I've got 2 antennae instead of just 1. The signal reception, I'm not even going to bother doing a range check on this model. I have the receiver set up the way it was set up the first time I flew it, and I would fly and have maybe 2 frame losses for an entire 3 to 5 minute flight. I'm not worried about it. I can do one just for the sake of it, but I don't think it really needs it. But it is again, the AR10360T receiver. I did have to forward program it to give it the setup that I want it. Pretty simple stuff as far as the installation. One tip I'm going to give you when it comes to setting up the AR10360T, I wish I could pull it out and show you, but actually I probably can if I just take this hatch off. You might hit the damn plane with my camera. You might be able to see it, but the servo lead plugs for the 10360T have notches built into them. The problem with that notch is when you get one, you'll see what I'm talking about. When you try to plug the servo lead into that, most servo leads don't have those notches, especially the ones that come out of a Freewing jet. So you're going to have to take a knife and you're going to have to cut the servo lead to give it those notches. So demonstrate what I'm talking about here. You'll see how this is a square pretty much perfectly right there. What you'll do is you'll take a knife and you'll cut basically a little notch like this. It could have been cleaner, but that's enough to get it to actually fit inside of the port. If you don't do this, when you go to pull it'll be really hard to push them in, and then when you go to pull them out, you're going to yank out the metal pins, and you'll have to just crush the whole thing with a pair of pliers and pull it out. It's a real pain in the butt. I already discovered this with my airliner, and I don't want to have to do that again. So just a thought process on that. There's still junk on the side of my plane. Sometimes when you hang these things from the ceiling, sometimes the little pads that I use to hold them to soften the pressure on the foam sometimes leaves residual junk on them. Okay, let's go back to my list. So we've already discussed the receiver. I talked about removing the blue box. Again, I'll mention, because I removed the blue box, I had to manually sequence my own landing gear system. That was fun. And by fun, I mean really annoying. It took quite a bit of testing to get it set up. If you've never set up a sequence, I will show you. For those of you who are 3D animation minded, it's actually very similar to doing keyframe animation. You're basically keyframing the animation of the door opening. So let's go ahead and show what it looks like. And I will potentially adjust it a little bit more while we're on camera here. So push this camera up a little bit so you can see what I'm looking at. Now, if you've ever flown a plane with Freewing's blue box and you didn't bypass it for the gear, you will know that those gear don't normally drop that fast. Well, they might drop that fast, but going back up takes forever. Mine is instant. And you'll know too that when the front nose gear comes into the gear well, it goes all the way in, and then the door kind of goes, and and then shuts. And then you have to wait for it to go and open back up. I don't have that issue because I sequenced it. So let me turn this back down so you guys can see what I'm looking at. You'll see that I've set the sequence for reverse, as in coming back up, to be 5 seconds, and for forward, as in dropping, to be 2 seconds. The reasoning for this is that the nose wheel takes a significant amount of time to come back up, and I want to be able to have the nose gear in the well or very close to it by the time I start the animation for the door closing, so I don't close the door on the strut. And I'll go over that. I use a door cycle animation set to proportional rather than step. I don't know why I keep calling it animation. Maybe it's just because I work in the 3D industry and I'm used to calling it that kind of stuff. Here's what the keyframing for it looks like. It's not intuitive, and I am not going to lie to you and tell you I understand every little bit of it. It's a lot of trial and error. When you do this, I'm going to recommend that, let's see if you can see what I'm seeing here. You take the servo arms and remove them from the horn. Okay, so you unplug the clevis, you unplug this, or not unplug, slide that off, unplug the clevis, let the doors hang free, and let the servo move up and down. If the servo arms are down, that means the door is open. If they're up, that means it's closed. That's how you're going to want to first set up the animation for this. Otherwise, you're going to run the risk of damaging the strut over and over and over again, or not the strut, but the door, by having it jam and smash into the gear strut. So how I've got it set, you can watch this little thing right here, this little arrow. You'll be able to see it move. So I believe forward is, okay, we're going to look at reverse. So you see the wheel starts the, actually I think I understand it now. The wheel starts the animation immediately, just about. And then as time goes on, the door moves up. So watch, you'll see what I'm talking about. Door closed right now. Okay. That's what the little arrow moving across means. So the gear already started its animation, and I was watching where the gear door was in relation to the little arrow, so I knew when to start making the keyframe for it. So you can do this by adjusting where you want it to start. That's what these little numbers up here mean, 100%, 100%, blah, blah, blah. That's referring to how much it's moving on the animation chart here versus where you want that to begin in the sequence. So right now it's starting at like 2.5 seconds into the, because it's 5 seconds of animation, so 2.5 seconds is halfway through. On the upside, this is 2 seconds worth coming back out. So you'll watch that the door almost immediately starts to deploy. I can make it even faster, but I kind of like where it starts, where it's got a slight delay, and then the gear comes out. And as the gear starts coming out, the servo door starts to animate all the way out for about half a second. So that's really all there is as far as sequencing goes. If you want to go the extra mile and reduce about an ounce worth of weight, you're going to have to do this to get rid of the blue box, unless you're planning to power it with lights. Like say you take these little foam bumps off the wingtips and you put your own light system into it, then I would say keep it, because then you'd want to have an integrated light controller. But I just used the Freewing LED controller version 3 and just connected it to the gear channel on a Y cable and plug that in, and just made sure to plug the nose light into it, and that seems to handle it just fine. So let's go ahead and bring the gear up for now and enjoy that sweet animation. I don't have anything against the blue box. I bypass it in general, not because I don't like it, but because I want to get that, and I can't get that with the blue box because it doesn't allow you to have that type of mixing. You have to bypass it if you want that. So back to my phone to figure out what I'm going to talk about next. Okay, so we've gone past sequencing gear. Now it's time to talk about receiver setup.
Safe.
So I've set this plane up as dual elevator, dual aileron, dual flaps, single rudder. I wanted to do 2 rudders, but I couldn't find an AS3X safe receiver that was also 12 channels. I would have gone with a 12-channel receiver if I could. I know the Spectrum website has them. They're ungodly expensive. It's like more than 60% of the cost of this ARF model just for the receiver, and it didn't even have stabilization in it, so I'd have to get a separate gyro, which would make the cost go up even more. So you'll see how this is programmed. As the left wing goes down, the aileron goes down to push it back up because it's in safe currently. As the left wing goes up, the left aileron goes up to push it down. You'll also notice the stabilator is doing the same thing. The stabilator is going up to push the wing down, and vice versa on the other side. As you dive down, the stabs push down to bring the nose up, and vice versa. As the nose goes up, the stabs go up to push the nose back down. So they're set up for full, again, they're set up to be Tailerons essentially in the receiver, but we're not using Taileron programming in the radio, and I'll go over how that's done. The reason I did this, it's not the most intuitive thing in the world, but I want you to realize that for guys like me and say Air Guardian, who's probably watching this right now, because he's just got his own F-22, we like to fly at the edge and get the most performance we can get out of these models. Air Guardian goes a little bit further. He puts in crazy motors and all sorts of other stuff. I like to see what I can get out of the stock setup, generally speaking. I'll swap servos, but I don't normally consider myself the type of person that would just go out and spend a ton of money on a motor yet. I had a spare motor. I wanted to see what the performance would be like versus the stock. The motor in there is a 12 blade, so it should have a lot of low end thrust for hovering and alphas and all sorts of crazy stuff. So I wanted my stabs to control for my AS3X in roll, or not AS3, I want it to stabilize in roll and pitch. So let's go ahead and throttle up so you can see it. Okay, now we've activated the system. I'm gonna jack it up because I'm actually using a mix, what did I call my flight control computer mix. You guys have seen my channel before and know what I'm talking about, but for those of you who are new to this, I will explain it in a bit when I get to the mixing section. But essentially, you see that my stabs are correcting for turbulence. So plane's flying through some crazy wind right now, and the stabs are keeping it level. What's going on too here, the reason why I want the stabs to work in this attitude is I want the plane to like hold stable Harriers, or not Harriers, but high alpha, whatever, it doesn't matter. We all know what we're talking about. But as the plane starts wing rocking in a high alpha, if you've ever seen any of my videos, and I'll try to make a picture-in-picture on this so you can see what I'm talking about from previous experience doing this. The plane in super high angles of attack with the stabs forcing the plane to hold it like this, you'll see the wings start to rock as one wing stalls, then the next one stalls. Having the stabs correct for roll would probably eliminate that entirely. I have some mixing that I'm going to do that'll probably reduce it or just outright eliminate it anyway, but having full stabilization on all axes is not a bad thing as long as it's set up correctly. So to get to the point where you have a dual elevator setup but you don't have it on the Taileron configuration inside of your radio, you have to do one thing, and I will explain it to you. It's pretty simple. You basically trick the receiver into thinking that it's a Taileron airplane. So we're going to go to the aircraft type. And before I do that, actually I didn't change any of the channel assignments, but if you did change the channel assignments at any point, you would have to remember what they were and change them back every time you change the wing type. Otherwise, it's going to default to whatever it thought it should be. The nice thing is with a 10-channel receiver, you generally don't have to change anything. You just go with what it showed you, and then you set up the servos and whatnot based on the channel assign that it's presented to you when you make the aircraft type. And then you don't have to worry about changing it at all when you go to do it. So 2 ailerons, 2 flaps, dual elevator, 1 rudder. We're going to go ahead and change that. Okay, we're going to change that to hit the wrong button. Change dual elevator, 1 rudder to Taileron A. Okay, you just change it to whichever one you think is going to work correctly. Let's make sure that the mixing works correctly right now because I already have a mix to make the Tailerons. But the problem with the Taileron mixing is it doesn't use the full stab, and I'll show you what I mean as soon as I turn it off. So if I go to aileron to left elevator and just go ahead and set the switch to inhibit, all right. See how I can pull the stick back and I'm getting more stab deflection? When I have it set to dual elevator, 1 rudder, my mix already forces it to be 100%. So when I go to roll, I'm getting the full roll rate of the Tailerons based on the mix because it's 100% aileron to 100% left elevator, and it makes both of the elevators move 100% of the aileron travel. You don't get that if you didn't if you're using the Taileron mix. And also you can't turn them off. They'll always be on, and sometimes you might want to turn them off. I don't normally do that, but you might want to, and that's what we'll talk about here. So to get it to understand that you are in a Taileron configuration, but go back to using dual elevators, here's what you do. You go to gyro settings after you've set the plane up, you go to system setup, you go to relearn servo settings, but make sure that you've already set it up as Taileron and that you confirm that the corrections are direct. Or the direction, yeah, corrections are direct. I got it right. So that means that when you go to use right aileron, as this aileron goes down, the trailing edge of the stab goes down with it. If you don't see that and it goes up, you're in for a rough time. Don't do that. That's bad. Okay, so it should look like this. Left should be up movement on both sides. And on the left side of the plane, left aileron should produce upward stab and aileron movement. On the right side, it should produce down instead, and vice versa. That's what you should expect to see. If it's not doing that, go and switch it. Or if you have to reverse channel directions, do that too. But whatever it takes to get to that point, do that. Once you have done that, you've confirmed that it's all working the way you want it to work, go to relearn servo settings and hit apply. The plane will restart. Okay, go ahead and back out of it. All right. Now we've got a plane that works with Tailerons in safe, which also means that because it's working in safe, it means that the receiver will use the stabilators to correct for roll. Okay. Now what we need to do to get back to the dual elevator so you can turn the stabs off for roll, and also to get more precise mixing out of them, is to go back to aircraft type and switch it from Taileron A to dual elevator, one rudder. Okay. Now, when I'm in safe, which I am right now, that's backwards. Interesting. So we need to fix that. I wonder why that's backwards. Let's double check something before we... Left, right. Okay, so I must have chosen the wrong setup. One moment. I could have sworn I had it right, and you guys even saw that I had it right. Not to worry, it's an easy fix. We're going to go ahead and go back to dual elevator, one rudder, and change that to Taileron B, and see how that handles it. Okay, now the RF reinitializes. See, that's backwards. That doesn't make any sense. Put it back the way it was, aircraft type. Taileron B will now be dual elevator, one rudder. Actually, no, Taileron A. Let's just make sure it's all working correctly before we go any further. I don't want to screw this up. Okay, that looks the way it's supposed to.
2 losses, 4 hold, holds 4.
Okay, and we're going to go to mixing, make sure that the...
Holds 4.
I don't care about the holds. Okay, I need to now turn off the telemetry warning for the flight log, otherwise it's going to keep telling me that it had holds forever.
Holds 4.
I don't need to be told that I had holds. Thank you. Okay, now that's going to stop. Back to what we were doing. So, surfaces are correct. They look correct again. Let's go ahead and tell it to relearn servo settings to make sure this works correctly, because I had it working fine earlier and now it's not. So always good to double check this stuff. Relearn servo settings, apply, complete, hold, model adjust to back all the way out. Go to, okay, that looks correct. Go to model setup, aircraft type, hold proceed, change Taileron back to dual elevator, one rudder. Okay. And that's still backwards. Let's make sure that it's actually rotating in the correct direction, because this doesn't make a whole lick of sense to me. See, it's working correctly here, so it is fine. That is strange, but I've seen weirder things when it comes to working on model aircraft, so we'll just choose to ignore it for now and go ahead and set the mix back up. As long as it's working correctly in the directions, I don't think it matters, because I'm going to go ahead and just re-enable the mix for it. So just go ahead and turn the switch back on. And everything's fine. but we'll just double check one more time to make sure that the directions are correct. It doesn't matter what's coming out of the transmitter, generally speaking. What does matter is if I roll this plane, that stab better go down on the trailing edge with the aileron. And it does. It goes up with it as well, so everything's fine here. The good thing about working with relative gains, too, is that I do have this set on relative. Okay, like I think I just said relative gains, I'm running relative, blah, blah, blah. This is my gain slider. Okay, I can turn that completely off. Let's go ahead and throttle back up real quick and enable the AS3X system. So if it was screwed up for whatever reason, say it wasn't going the right direction, even though I'm pretty sure it is. Yeah, it's totally fine. But we're going to go ahead and jack it up real quick so you can see what I'm talking about. Okay, and then hold the plane, rock it back and forth. This is all critical stuff, so I hope you guys are learning something from me here. Okay, that looks great. Let's say that the stab was moving down as the aileron went up. So the trailing edge went down as the aileron went up. So they went in opposition to one another. That wouldn't probably be the most horrible thing in the world, but I wouldn't recommend flying like that. If it starts acting weird on my transmitter, I can just slide it all the way down. And I've got no stabilization. So if it did feel like it was tail heavy or sluggish in the air, that would be my first thought, would be to disable that system. Just go ahead and slide it down, get it back on the ground, test it out, make sure it's working correctly. So that is how you set up the receiver so that it functions in the correct direction. I'm not ruling out the fact that maybe my Taileron mixing is being adjusted by something else in my mixes, so it's nothing to worry about. Again, because we'll just test it one more time, so those of you guys who are watching will have, you know, the proofs in the pudding kind of thing. Up, down, and then flip it upside down. That's all that matters. As long as those directions are correct and the receiver is trying to point it in the correct direction as it's flying, and your transmitter is pointing in the correct direction as you fly, that's left, that's right, everything is fine. There's nothing to worry about. So that's how you get it to have pitch and roll stabilization on a full flying Stabilator like that. Back to my phone to see what else it is I need to talk about here. All right, let's get into mixing. This is the fun stuff I love talking about. This one I'm going to take a seat for, because it's going to be a while. All right, for this, to get Tailerons on a dual elevator setup. Sorry about that, I was just thinking, it took me a moment to process what I was trying to say. So to get it so it's not like this, but it's like this, you need to create an aileron to left elevator mix. Because I'm using a 10-channel receiver and I didn't change any of the what do you call it, the servo positions in the channel assignment, there is no programming bug to worry about that you guys may have heard me talk about in other setup videos. What'll happen on 8-channel setup is that you go to make like a full flying Stabilator mix, and you got each one of them on independent channels. For whatever reason, the Spectrum Airware will automatically set left elevator to channel 9, even if you set it up as an 8-channel airplane. So you only have 8 channels to work with. aux3 gets set to aux3, but channel 9 isn't supported by an 8-channel receiver, because you can't, I mean it is, but it's not a physical servo port. So you go to change left elevator to aux3, and then you change aux3 to left elevator. What ends up happening is you have to assign it to what was channel 9 to get that Taileron mix, which would end up being aileron mixed to auxiliary 3, even though it's really mixing to left elevator, because it still thinks it's in that position. Because the way the channel assignment works, again, is that it's not really working based on what channel you tell it to work on. It's often working based on the numerical value that it's looking for. So it thinks that left elevator should be channel 9. Even if you set it to be channel 8 in here, it's still going to mix it. You're still going to have to move it to channel 9. So if you set aux3 to channel 9, even that says aux4 and left elevator is in channel 8, I know this is confusing, just bear with me. What you get is a mix to channel 9 to get channel 8 to work for the roll control. It's so goofy. But that's not a problem with a 10-channel setup, because it's all where it's expecting it to be. All right, so I had to make a cut here and put this thing on my stabilization stick so you could actually see what I was talking about, because once I start talking about aerodynamics and mixing and whatnot, I kind of get lost in the zone and I forget that I'm looking straight down at my transmitter and not actually looking with my head so that you can actually see what the surfaces are doing as I deflect them. So we're going to start with the second mix on here, which is my aileron to left flap mix. This is a curved mix, okay? And what a curved mix does is it allows you to set points, which you can see there. There's 4 different points. I'll get nice and close so you can see them a little bit more clearly. And the points generally allow you to determine where on the model certain things happen. So as I go to roll the plane, you'll notice that the Flaperons aren't moving 100% with the ailerons until, get a little higher, until full deflection happens, and then they meet up with them. And vice versa going down as well. This is by design. I basically added my own version of Expo into the center of the curve by limiting how far they can move, which is why you don't see a linear straight slope across this. Let me go ahead and put this thing down so you can see a little easier here. All right, so what this does is went ahead and I added a point, which you can do with most transmitters, but in the IX20 it's super easy. You just hold the stick to where you want the point to be, and then you add point. You can kind of see it right there. And then added a point at -25 and +25 on the roll axis. At point number 2, which is rolling right at 25, I added 14%. And at point number 4, I added -14%. So that's -14 and 14. So the Flaperons only move 14% of 150%, if that makes sense to you. At full deflection, they're 150% and 150%. You can change how much they actually deploy to reduce how much effect they have. So like if I set it to 0% here, what I would get is no effect whatsoever on that axis. Likewise, if I was to make it 100%, just barely moving it this far would cause it to immediately deflect to 100%, which with 150% rates means it deflects to 150%. That's a curved Expo mix. I'll go into that with the stabs here in a second. So the next mix is aileron to left elevator. That produces the roll that we're looking for in a dual elevator setup where you don't want the Tailerons being artificially limited, because that's what happens with a Taileron mix, is that it limits them to about 112% rather than 150%. And as you pull back the elevator and then add roll to it, then it adds the remaining amount of stab movement. Whereas I just want that stab movement the entire time I pull the stick, not at like certain specific moments. So again, we have an Expo curve here, which produces a smooth response rather than a point response, as you can see there. It makes it smooth out over the course of the mix. So point number 1, which is all the way to the right, is 100%, which means 150%. Point number 2 is 36%, which I can't do the math on the fly, but it's nowhere near as much as it would be if it was, like a linear response. That's 36% set at 50%. So I'm actually reducing it's like basically Expo. This is a decent amount of Expo. So at 50%, it's actually pulling 36%. It's all mirrored to the left roll as well. If you want to see what it looks like on the model, here's what that looks like. So this is at 50% roll right here, and then 100%. If I want to make the stabs do almost nothing when I roll until I move the stick all the way to the outboard, what I can do is change point number 2 to about right here, so 10%. Okay, now when we go to roll, I think it is left. No, roll right. When we go to roll right, watch the stab, then you'll see what I'm talking about. So rolling right, this is 50% right here. This is where it starts to take effect, and then at the end of the stick, it deflects all the way. So you can keep the Tailerons if you want them to run all the time, but they barely do anything up until the specified point that you've set. This is a really good way to have that stab authority and then only activate it when you really want it. I personally like having them on all the time, so I prefer having them be this responsive. And I'll just move the stick just halfway to get this much deflection. That's what I'm used to. Your flying style may vary, of course. Next setup item is going to be our deflected ailerons and crow mixing. Okay, and switch F being at position 0 does nothing. At
Deflected ailerons.
position 1, negative 44% causes the flap to move the ailerons down.
Full flap.
Okay, you'll see the elevator's moving as well. This is all eyeballed. You can adjust this on the fly to your preferences. But this will produce a very nice, slow, easy to fly airplane at lower stall speeds. I would say that it would be more aggressive in the stall, and I would probably be very likely to be correct, if not for the fact that in the earlier segment you saw the reason why that I had set up the roll gain on the stabilators was to make it so that the stabs could prevent the wings from dropping. As the plane pitches to the right or to the left, the stabs will correct for that, and hopefully to a certain extent, very much like the real F-22, because the real plane is fly-by-wire. Setting it up the way I'm setting it up, and hopefully the way you might consider setting it up, you'll also get something that's very similar to fly-by-wire. It's not going to automatically reduce gains based on angle of attack and your airspeed and whatnot, but you'll get a pretty similar effect out of it. Okay, moving to position number 2 on switch F will give us crow.
Crow.
This will probably produce even better landings than the deflected ailerons, but it won't. I don't know if it'll look as cool, but the full-scale jet does use both. I've seen videos of them landing with deflected ailerons. I've seen them braking in the air using crow. Crow, for those of you who ask me constantly what crow is, crow refers to upward aileron movement as flaps move down. It is a high drag lift destruction technique that's really effective on the ground and incredibly effective in the air. This will produce another interesting effect too. I'm not sure if it will do it as much in this wing type because this is a Delta jet, but it should theoretically reduce the amount of wing incidents at the wingtip, causing it to have negative washout, or sorry, positive washout, which should then make the wing less aggressively bite into the air at the wingtip, which would encourage the wing to stall at the root where the flap is, versus at the wingtip, preventing the plane from nosing over as easily, like tilting as it stalls, which should produce a more favorable stall response. I mean, I'm pretty sure the plane already has a pretty good stall response from what I recall flying it the last time I flew it back in September when I had my older version of this model with the stock setup. What should happen is the plane would just nose down without dropping a wing. It'll just come straight down, which is preferable to dropping a wing because that's when the majority of your unrecoverable stalls and major damage and wrecks happen. The crow mix is really simple. It's 60% positive with flap to left elevator on the IX-20 and I think some of the newer Spectrum radios. You can just have the same switch control, different positions. You don't have to make a whole new mix. That's how I do it. It's pretty good stuff. I have my elevator set up to compensate as well. So you'll see that when I have deflected ailerons out, the stabs point up to produce a counter effect to the ailerons drooping. When the ailerons droop with the flaps, it will aggravate the tendency of the plane to want to pitch down because they're pointed down, like they're basically being treated like elevators pointing down. So you have to counter that with the elevator. Countering it with the elevator also increases drag, which also reduces your airspeed even more. So you need to be, Johnny on the spot with throttle when you're working with any kind of flap, because you have to overcome the tendency of the plane to stall as the airspeed reduces. You need to be able to maintain lift throughout. You have to fly the plane, basically. You got to fly it all the way down. With crow, the opposite is true. You don't want upward elevator movement. You want downward elevator movement, because the upward moving ailerons are going to produce a pitch up response, and it will be quite severe. If you ever test it without putting any elevator mix in, you'll see what I'm talking about. Hell, you'll see it with deflected ailerons. The nose will immediately point. You'll go like this, and it'll just go like that. And I've done it too close to the ground and nearly scared a Tootsie Roll into my boxers. So learn from my mistakes and don't do it close to the ground. Test this stuff in the air. Test it up in the air for sure. There's your aeronautical theory for that kind of stuff. Let's get back down to the mixing. And let's look at my favorite mix that I've come up with, which is going to require that the gear drop. So let's go ahead and get the gear to drop. Okay, gear down. So this is my spoiler mix. This can only be activated because it's a combo mix. It can only be activated when the gear are down. It cannot work when the gear are up because I have a combo switch on this. So to set that up, I have switch C set to being the primary switch, so in position 1 and 2.
Spoilers.
Okay, that activates it, and switch A has to be down in gear mode. The gear have to be dropped. What this produces is a flap to right flap, or sorry, elevator to right flap and elevator to left aileron mix. There's 2 mixes for this, and they're on a curve because I want it to pop up in a very specific way. So as I pull the elevator back to position 15, I have points 1 and 2 set to negative 100%. Remember I told you about how you can make these curves as crazy as you want to make them and have things pop up as fast as you want or as slow as you want? This is how you do that. Okay, and we're going to go ahead and I'll show you the effect of it in a second. This is what the real F-22 does, but let's go ahead and get to that point first. Elevator to left aileron. Next thing is pulling up on the stick at negative 20 because I want it to look kind of like the real plane where not all the surfaces move at the exact same time. Sometimes they have a slight lag. That's just personal preference. You can just do it at the same key point if you want. Instead of negative 20, you'd set it to negative 15. Same response, 100%, 100%. Okay, what you get is really effective spoilers. If you've seen me fly my Extra 300 and you see me do that Harrier mix on the ground right as I come into land, you see this. That's what you're seeing. Notice how little elevator input I'm giving it? That is what an F-22 does on landing. Once you have positive wheels touching down and the nose gear is down and the computer realizes you need to slow down, the fly-by-wire system automatically deploys the spoilers. So imagine the gear just touched down, everything pops up to slow this big bird down as fast as it can get slowed down. That is my spoiler mix. I'm going to test that out on Tuesday. Now that I've got the full movement of the Flaperons and the Ailerons, I can't wait to give it a shot. If I had had a 12 channel, I would have made it so that I could have the rudders, the right one would point that way and the left one would point that way, so they'd all point outward to slow the aircraft down even faster. When this plane goes into crow config, they will actually tow outward like that. That is pretty much all the major mixing for flight control stuff. For some gimmicky stuff that you'll have some fun with, I'm going to recommend that you look into trying this mix out.
FCS normal.
Ignore that. That's just me telling myself that the wing is flying normally again. To get those nice power loops that you've seen me do in previous videos, that I'll go ahead and if I can find the archive footage that I've had shot before, I'll show you what it looks like in a mini player here. But on switch B, channel 1, I've got it set up on a curve mix, so as I keep pulling the elevators back, nothing happens until the very end, and boom. The elevators dump all the way out, or the flaps dump all the way out with the elevators, which causes the plane to immediately backflip over itself, just like the real plane would, as though it has thrust vectoring, but it doesn't have thrust vectoring because it didn't come with it stock, and I really don't want to mess with the model too much. I might get a different fuselage and try it at some point, but for now I'm quite content with what I've got. That is a really awesome mix. I do it, and it gets a lot of attention from people. Pull back, and then bam. I could even go further and make the ailerons pop down with it, and I might even consider doing that. But I'll show you how this mix is set up real quick. Come on. This little stick doesn't want to remember where my positions were. So for that mix, it is an elevator to right flap mix. So that's going to make the flaps move together in concert. As I pull back, everything's fine until I reach position negative 80, and then it pulls back 100%. You can kind of hear it working in the background. That's what causes that. I also have the same mix that I used in my Viper 90,
Alpha Crow,
which I'm going to try out on this plane too. It's just pulling the elevators back, dumps out crow. It's a little easier to see from above. The wing rocking is very pronounced in this jet. When you hold full elevator back, when the stabs are holding this plane up in the air, the wings are just kind of going side to side like this over and over. One wing stalls, and then as it drops, the other one begins flying a little bit less and the one that's dropping gains airspeed, and it starts flying again, and it just keeps dancing back and forth like that. It's not what you want to see when you're doing high alpha maneuvering. It looks very unstable, and it starts getting sketchy, and honestly, I usually power out of it when that happens. I don't like it. It makes me feel weird. If I like the way my Viper 90 handles high alpha, the way I forced it to with that Crow mix, because there's almost no wing rocking at all, and it just flies entirely post-stall. This plane can do that too, and I'm pretty sure with this mix it will. If it doesn't, I'll change the flaps so they don't move, or maybe even have them move up to reduce the wing area. That might even help it fly entirely on the duct. That is basically all the mixing. There's some other stuff I might do in the future, but for now that basically covers everything on how to set up a 90mm Freewing F-22. I really hope you guys enjoy this kind of content because I love making it. I'm actually gonna get this thing to stabilize. There we go. I'm actually gonna work on the F-14 here pretty soon. I've got it set up in its little stowed away carrier configuration in my newly redesigned hangar space up here. So I should be able to get some pretty sweet explanations on how to fly that thing. The maiden should be coming on Tuesday, for better or for worse. As you guys have seen, I don't edit my maidens to make them look better. If they go wrong because the nose wheel was castering and I didn't realize that it was castering, they just go wrong, and you guys see every little bit of it. Looking at you, F-18, as you guys can have seen, that maiden will attest. Oh, quick addendum, something I forgot to mention. You've seen my crazy, ridiculous rates. Again, let's go over some of the other stuff before I wrap up. Just as I remembered as I'm going down to edit this footage, I'm like, oh crap, I didn't go over the rates and how I fly with these, and why you shouldn't fly with rates like this without Expo. Expo is not a bad thing. I wish people would stop demonizing it. It's not a crutch any more than drawing in Photoshop is a crutch, any more than creating 3D models is a crutch over sculpting in clay. It is a tool to use in your arsenal of radio control. Please use it. If you don't want to use it, that's cool, but don't disparage people that do. Don't be part of the reason why this hobby's dying. Try to welcome new people and be friendly with them, and show people that just because new technology exists doesn't mean you're any less of a pilot. As the guy that did the F-22 flight control demo at, I think it was Stanford University, said, he could put his kid in an F-22 and it would be easier to fly than a Cessna. In fact, he could probably put the kid in there and it'd be fine, because the plane can basically fly itself, in his words. So I'm going to go over my Expo, and I'm going to go over my rates. So before I go over my Expo, let's go over my rates. I'm flying with 150% rates on all surfaces. That includes rudder, that includes stabilators, that includes flaps, everything. I firmly believe in 150% rates when you're flying aircraft that are 3D capable, or even if you're not, if you're flying planes that are not 3D capable, you'll get the most out of them by having the ability to grab the air at all airspeed and work within the limits of the airframe as it pertains to the speed you're traveling. If you have these giant deflections at low airspeed, they make a big difference. Let me go ahead and turn that mix off so you can see what I'm talking about. Like, a lot of people will fly the F-22 and this is their max travel, and they're afraid that something's going to rip off this plane, or it's going to crumble into 1,000 pieces if you pull too hard, or the stabs are going to rip off. That's not going to happen. This plane is incredibly well engineered. In fact, none of these planes are like Real Flight 9.5, where you go to pull too hard and they explode into a bunch of pieces. I have made this plane do an 11G pull into a Cobra before by looking at my G-force readout after the flight. No visible signs of stress, no visible signs of any cracks or any other issues. It worked perfectly fine. There was no problem. I've made some impressive Cobra maneuvers with this plane that I'll make sure to put in the what do you call it, a picture-in-picture for you so you can see what I'm talking about. But these stab movements, while they're not going to damage the plane, you're going to crash it if you go to pull it just a little bit and it's moving this much. It's not a linear, like, Air Guardian will tell you this, and I'm going to tell you the same thing. No Expo is, just in my personal opinion and the way I look at these things, it's not a good way to fly these things because there's no true linear response one-to-one. Like, if I turn off my elevator Expo, which is currently set to 80%, so if I change this is 80% right here. If I change this to nothing, That's me moving it the same amount I was just moving it. You see how much crazier that is? There is no difference in the control. There's no delineation between the I can't really put this in words, I guess. What I'm trying to say is it's just going to be over controlled. You need that Expo. You need it because when you go to pull halfway through the stick, it's only going to move this much, but it's going to feel like you're pulling all the way down on the stick. And then when you really need all that stick travel, you've got it. So you can just get used to flying in the center of the stick because your throws are so huge that you don't need to go any further. And you can just feel the way the plane is flying. You can tell that it's responding in a way that makes sense as you're flying it like this. So again, 150% rates on my Expo. Again, on pitch, I'm flying with 80% Expo. On the ailerons, it's 85%. And on the rudder, it's 90% because those twin tails are incredibly effective. And what happens a lot of the time with the stabilization on the camera is not working. What happens a lot of the time, there it goes, is you go to give it too much rudder input and the plane just immediately flips over and does a snap roll. If you get the center of gravity far enough back on this plane, you might be able to hold a stable knife edge. Or hell, even with the stabilators working with what do you call it, roll gains, the way I've set them up, I might even be able to start doing knife edge passes because the jet will actually try to hold that attitude a bit easier than it was before because the stabs are only working in pitch. So that's my rates, that's my gain, but there's more to this story than just that. Okay, and watch what happens when I pull my gear out. Watch that stab movement and watch the surface movement. See how much more that lowered just now? So this is the extent of my pitch when I'm in gear, when the gear are out. Same with roll. The stabs do move more with roll when you go to, like, this is pulling back and left. That causes it to multiply the roll against the pitch, so you get a little bit more out of it. There's a really good reason for this. This is what I call gear-based rates. There is no fly-by-wire system that I'm bloody well aware of that allows you to have full stabilator movement when your gear are out. Okay, this is currently what am I running at right now? With gear down, I have 30% Expo at 47% rates, which causes, 47% 150 is 70%. So 70% rates and 47% on the elevator with 30% Expo, which might even still be too touchy. So I'm probably going to change that actually to 50% now that I'm thinking about it. And the reason why no jet has, no fly-by-wire jet has full authority when your gear are out is so you don't over-control the plane and crash it. The computer's not going to let you do that. Its first instinct is to preserve the life of the pilot and the airframe if possible. It's not going to allow the plane to be over-controlled if it can potentially stop that from happening. So the reason for that obviously is because with all these deflections, you don't want to end up crashing your model jet. It's just an F-22 that's made out of foam, right? But it's still really expensive. I mean, all the stuff I put into this plane, it's a $700 some odd plane. It's a lot of money. Point number two to this, see these giant stabs? See how much they're pulling down? I have flown this jet off grass, bumpy grass, and I'm pulling to try to get this plane to lift off, and it just doesn't want to lift off. And it starts bouncing, and that tail kind of bounces back, and these stabs are all the way out. What ends up happening is the tip of the stab grips the ground. It hits the ground, it rips it right out. So you end up flying with a chunk of your stab missing. So you end up missing like this much of the stab. You have to go find it in the middle of the field. It'll still fly. It just looks ugly as hell. So keep that in mind. Gear-based rates are your friend in jets like this. Absolutely. I use it in all my jets. My airliner has it too. The Delta hanging up from the ceiling here. Although I don't use gear-based rates on that, I use gear-based Expo. It's 100% rates on everything, but then when the gear drop, the Expo just goes a bit higher. So the plane is, it's not going to end up being over controlled, but I don't reduce the throws that I absolutely need to fly the plane correctly, because it's even with the weight I put in the tail, it's still nose heavy, so I still need to have that level of authority to fly it correctly. The Viper jet over there, same thing. The Yas 39 Griffin, same thing. The V1200 even. Well, no, I have gear-based rates for that one. That's another thing I didn't cover too. Let's go over that real quick while we're talking about mixing and whatnot. I forgot to show you my my gear-based flight control mixing. I gotta talk over this gear. It's very loud. That was the one mix I didn't show you guys. I should have written all this down. It would have been easier. I get scatterbrained when I talk about this stuff because I have so many ideas in my head and so many things I want to talk about. All right. On my iX20, I'm actually using the 12th channel for this, or sorry, 13th I think it is, which is X+1. All right, there's two rates for this. There's gear-based rates, and this is controlling the stabilization system. I'm actually going to show you how the receiver is set up too real quick. I'm going to have to cut this video up a little bit. It's maybe not going to make the whole lot of sense, but let me go ahead and take this thing apart, put it on my head so that you can see me holding the plane and see how the rates are behaving. So all right, 1 second. We're back. This is going to be a fun video to edit because my thoughts are all over the place. I even thought I'd got it all set up correctly by writing it down. There's just so many things to cover in this subject that it's not easy to cover everything all at once. So let's go ahead and begin with what I was talking about. So I'm going to demonstrate what this gear-based, or not gear-based, what is gear-based actually, gear-based throttle to AS3X gain mix does. So you should be able to see my screen right now. If you can't see it, I'm going to go ahead and just describe it anyway. So what you'll do is enter forward programming. Follow along with me on this. Trust me, it'll work really well. Make sure that you set your gains to some kind of slider. If you don't have a slider, then I guess you could probably just put it on a switch. You just won't get fine-tuned control of it. Set your AS3X gains to 70% roll. You want less of this than you want pitch. In fact, I'm actually going to set the pitch up to be even higher. I'm going to set it to 100% on all modes.
Heading.
So on my heading mode, I'm going to set it to 100%.
Safe.
And on my safe mode, which I barely use, it's just there for orientation if I ever lose it, 100%.
AS3X.
Okay, so 70 roll, 100% pitch, 90% yaw. It sounds like a lot. Trust me, it's not. You'll see right now, my roll is actually 20, my pitch is 29, and my yaw is 26. When you go to capture gyro gains, you'll see what it really looks like. If you're using adjustable gains, which you should be, you'll see how it works as I increase the slider over here. Watch this. So if I move the slider from the center point to the top, I get 55 roll, 80 pitch, and 70 yaw. Likewise, when I pull it all the way down, I get 0 on all three. So right now, with no throttle input, I get 20, 29, and 26. What this actually looks like on the model, instead of egghead talk, is this. Just a little bit of deflection, right? This is with gear up. There's two rates. There's one with gear down, which has a ton of stabilization, and there's one with gear, with gear up, where it has very little. So let's go ahead and go back to the mixing channel, or page. Go to the first mix, which is throttled to X+1, and you'll see that I've got a very shallow curve. The first point starts at -40%. Halfway through the point, it goes to -52, and at full authority, it has almost no effect at -90. What that looks like at full power is this. Very little effect. So that all changes, however, when you get into landing gear. When the gear come out, it becomes a whole different game. But when I have the gear up, I don't care so much about stabilization because I'm not doing anything critical. I am doing critical things, but I'm not in a position where the plane is likely to crash. You're most likely to crash at takeoff and landing. You want the most stabilization at that point. So you're going to set this curve so that switch A controls it. So with the gear up at 0.1, it has little effect through the throttle range. When you are in gear, you'll notice it becomes completely different now. The base starting value, even with no throttle, is 0, which means it's half of 75. I don't know what that would be off the top of my head for the roll, but you'll notice the difference is much more pronounced. This is also affecting the stabs too. The ailerons don't look like they're moving all that much, but don't forget that those stabs are massive, and they make a huge difference in how the roll turbulence is handled and whatnot. Okay, as I throttle up into about where I'm going to be landing with thrust, this is about where I normally keep my stab equipped jets with flaps. This is about where the throttle setting I normally
30
use.
seconds.
If you ever see me landing, like if you watch my F-15 video, you'll hear it coming in with thrust. I never land them dead stick. And the reason being is because I want them to A, have that stabilization mixed in, and B, not stall as easily. This plane is going to be rock solid in the air like this. It's not going to go anywhere. Even in heavy winds, it would still keep a pretty good straight wing. As the throttle increases to half throttle, you get this effect. Not as pronounced, but still there. And then at full throttle, it's not as pronounced, but it's still there. Normally, by that point, if I ever go to full throttle at landing thrust, I just clean the jet up, pull the flaps back, and pull the, the gear up. Now, this becomes really important too if you use the deflected ailerons and crow. I'll show you why this becomes important. So let's say I go back into landing thrust. If I didn't have my stabilators working to correct for roll oscillations, say from turbulence or just, maybe from an impending stall, the ailerons would do nothing. They're both pointed up. But now that the stabs are working in concert with them, what you're getting is additional stability that wouldn't be there in those special modes that the plane has. As you keep rolling the plane, see how it continues to correct for it? That is why you want to have roll stabilization on your stabilators so that you can fly it in various wing configurations, or you can have, again, full span flaps or crow or whatever else you want, and you still have turbulence stabilization and you still have stability mixed into the jet. Like you've still kept the fly-by-wire system going as best as you can get it in a $450 ARF from Motion RC. That should cover everything. I really hope this helps you guys out. I hope you find it super informative. I haven't flown it with Flaperons yet, but I have flown many jets with stabilators working in roll to no ill effect. You just have to reduce the gains a bit on the roll to compensate because the stabilators tend to be huge. It was most pronounced in my E-flite F-16 because when I went to go have Flaperons dumping out, what you would get was no roll compensation at all. So if you got a strong gust of wind that only caught one wing, well, guess what? You're out of luck. The plane's going to roll and crash. But with the stabs correcting for that, what you get is, a stable plane as it comes in to land with a nose up, which is how F-16s generally need to land, full scale or model. So that should cover everything. Again, this is John at SynRC. I'm tired of talking. I hope you guys enjoyed. See you next time for the F-14 setup video coming tomorrow.